WGI UAS Shallow Water Test. I'm Eric Andelin, Geospatial Program Manager with the Wantman Group, located in the Tampa office. This presentation will focus on determining the feasibility of UAS in shallow water applications, and by that I mean wildlife counts, vegetation identification, and scarring. We'll also cover the acquisition, processing, and some of the analysis. The location. We chose to perform our first test at Piney Point. The reason? Hillsborough County does not allow UAS operation in its reserves. This location is just south of Hillsborough County in an isolated location. Feasibility. UAS are well suited for shallow water applications. FAA regulations allow for flight under 400 feet without a waiver. High resolution is very important for these type of applications, as well as the ability to mobilize when proper conditions are present, and/or the ability to mobilize to difficult locations. And of course, they can be very cost effective. Shallow water applications. Wildlife counts. Due to the low altitude and high resolution image capture capabilities of UAS, it is possible to count birds, fish, rays, you name it. Underwater vegetation. The ability to accurately identify and quantify underwater vegetation requires high-resolution imagery, clear water, and calm conditions. Scarring. Scarring vegetation beds is a real problem in Florida, and it's punishable by law. UAS can quickly assess damage caused by watercraft. This is because of their ability to be rapidly deployed, and of course the high resolution imagery they collect. Acquisition. Let's look at our project. For this test we used the Firefly 6 Pro, primarily due to its ability to capture large areas per battery at a low altitude in high resolution. However, I must say, this system is VTOL, vertical takeoff and landing. And this becomes very important when you're working near shorelines, because on one side you have water, on the other side you have vegetation, trees and so forth, and you may have a little sliver of sand from which you can take off and land. Our flying height was 300 feet. The acres covered were around 80. The overlap, 80% forward overlap, 80% side lap, and the image resolution was 1 inch. This is our mission plan. We upload this information into the UAS and it executes that mission. The conditions. For this project, the winds were 12 knots out of the east. We had a slight chop on the water due to that wind. Clear water. Our acquisition was around 10 a.m. We did have some reflections from sun angle, more likely from the winds and the slight chop on the water. Optimal conditions would have been winds under 10 knots, calm water, clear water, same acquisition window, 10 a.m. to 3 p.m. with minimal reflection. Again, this is our planned mission. This is what the actual mission looked like. Each dot represents a photo point. It's also a GPS trail. You could see how the wind was pushing the aircraft, which allowed or created some gaps. However, we had enough overlap, it wasn't an issue. Let's look at processing. The first thing we do is remove unnecessary data. In this project, we collected about 950 images. So we decided it was time to remove the terns. Removing the terns took us from 950 images down to around 720. This eliminated over 200 images. And when you think that each image consumes storage space and eats up processing time, if you can eliminate them, go for it. Then we move on to automated tie points. Automated tie points over water can yield poor results. The blue dots represent zero matches, most likely deeper water. And these are areas where there wasn't enough definition between two sets of images for the system or the software to clearly define those. However, we do also do a bundle adjustment, and this yields some improvement. Then we generate a coarse DTM. No need to generate a higher quality one. We're working over water. The goal here is not to build a surface, but to support the ortho rectification and mosaicing. Orthos and mosaicing. You can see the individual images overlapped on each other in the screen to the right. You'll note that the sun reflection is different when the system is flying away from the sun versus when it's flying towards the sun. This is the ortho mosaic together. Given the wind conditions, the overlap ensured no gaps due to motion, pitch, roll, or yaw of the UAS. Image cleanup. Here again is the mosaic with the photo points. You'll note the black rectangle. This makes it hard to see the underlying imagery. The solution is to crop the area and add an alpha channel. Now we have something to analyze. Let's look at wildlife. Fish counts are not possible with COTS, commercial off-the-shelf imagery. But they are there, and you can count them. And you can quantify them. And this is due to the higher resolution UAS imagery. Underwater vegetation. Determining mass is not a problem. Not sure we could identify species yet. Scarring. Again, COTS imagery not collected for this type of identification. However, you could see the purple lines. We were able to extract some scarring. If you overlay the UAS imagery, you can see a lot more information. The green lines represent the scarring seen in the UAS imagery. So our preliminary results are good. However, further testing is needed. Data should be collected under optimal weather conditions. Polarizing filters might minimize the sun reflectance on the imagery. Acquisition at a lower altitude will improve resolution. And experimenting with overlap and side lap to improve the results. We should also experiment with RTK. This may improve the processing solution and/or geospatial accuracy if necessary. Some of the project metrics getting under the hood. Project date was 4/21. Time on site, setup, acquisition, and breakdown was around an hour. We did have some visitors very curious about UAS operations. We're always happy to explain this to folks and give them a quick tour, so that was fun. Our processing software is SimActive. The time processing was around 2 hours, probably less. The editing and analysis software is QGIS. Time editing, 30 minutes or less. Time analyzing, well, that goes on forever. Questions. You're always welcome to email questions to myself and/or Chad listed below. We thank you for listening to our presentation. Here are our offices statewide.